In this video, I'm going to teach you about average atomic mass and how to calculate it. So the average atomic mass, if you remember when I talked about this in class the other day, is a weighted average mass of all the isotopes of an element. That is why it can be a decimal. When you are calculating the average atomic mass, it really takes into consideration two things about each isotope of an element. We take into consideration the mass of each isotope. Remember, an isotope is an atom that has a different number of neutrons. That is going to change the mass of that atom, so we are going to have different isotopes that contain different masses. And we also take into consideration the relative abundance of each isotope, which we'll talk more about in one slide. And when we calculate the average atomic mass, that is going to be equal to the atomic mass that is located on your periodic table. So it's really nice because you kind of naturally have an answer key in front of you. When you go through some of these problems, you can check your work on the periodic table most of the time. The relative abundance of isotopes refers to the amount of each isotope for a given element. Okay, elements are found in nature as a mixture of different isotopes. So for carbon, there's 3 different isotopes. There's carbon-12, carbon-13, and carbon-14. Okay, the percent abundance of each of those isotopes is going to be constant. You see in the image in the bottom left-hand corner, carbon-12 has a percent abundance of 98.9%. Carbon-13 is 1.1%, and carbon-14 is basically 0. If you were to find some carbon and find the relative abundance of each of the 3 carbon isotopes in the sample that you found, you would find that the percent abundance of each of those 3 isotopes of carbon would be exactly the same as what you see in this diagram. Okay, so the percent abundance of each isotope is constant no matter where you're finding your sample. It's going to be those percent abundances. Now, when you are calculating your average atomic mass, your answer or your calculation should be closest to the most abundant isotope. So for instance, copper has 2 naturally occurring isotopes. We have copper-63 and copper-65. If you look on the periodic table, the average atomic mass that is reported to you is 63.546. Okay, we can tell by the average atomic mass and looking at the mass numbers of the 2 isotopes of copper, which isotope is more abundant without having to do any math. Right, so we have copper-63 has a mass of 63, and copper-65 has a mass of 65. The average atomic mass is closer to 63 than it is to 65, so therefore we can conclude that copper-63 would have the higher relative abundance because the average atomic mass is closer to 63 than it is to 65. Okay, it's just kind of basic statistics. So the general equation we are going to use to calculate the average atomic mass is going to be on the screen in front of you. I would suggest that you write it down. You're going to take the percent relative abundance for the first isotope, multiply that by the mass of the first isotope, and then you're going to add that to the product of the percent relative abundance of the second isotope and the mass of that isotope. And you can go on and on and on. Not every element only has 2 isotopes. So if there maybe is 3 or 4 isotopes for an element, you would have to go on and add the product of the percent abundance and the mass for isotope 3, and add the percent abundance times the mass of isotope 4 as well. And then you are going to divide all of that by 100 to find your average atomic mass. The next 2 slides have 2 practice problems on them, but I recorded myself completing the problems on paper, and I uploaded those videos onto the slides. So if you could go into the slides link on your document for today, on the last 2 slides, just open them up and the video should play. It'll show you how to do these calculations. Okay, that's it.